This is JEE Advanced 2025 question, and in this we are given two plates P and Q, and they are radiating like a black bodies, and we have to find the amount of heat transfer. Initially it is given that plate P is at temperature Tp and Q is at temperature Tq, and it is given that means Tq is less than Tp, or you can say that this plate is at higher temperature, and subsequently two more plates are inserted, like 1 and 2 here, and we have to find and the heat transfer is taking between first and second, and then from second to third, and then from third to fourth. So we have to find the ratio of heat transfer when there was no plate inserted to the ratio of heat transfer when there was two plate inserted. So this seems quite daunting initially, but it is a very simple question with two-line solution. I will explain it gradually. So what are the key concepts required here is, first is your Stephen-Boltzmann law, that is P equals to sigma into T to the power 4, and the power exchange between two bodies in which suppose one is at higher temperature, the net heat transfer is sigma into T1 to the power 4 minus T2 to the power 4. And when we are inserting further two plates or n plates, then what will happen is net heat transfer will be reduced, and they will behave like a resistor, uh, and overall the net power when the two plates or n plates are inserted, net power will decrease, and the formula is given as sigma T to the power 4 minus Tq to the power 4 divided by n, where n is number of plates that is inserted. I will explain how this happens. This is the formula that is required to solve the question. It is a very simple question. Suppose we have two plates as given in the question. Suppose Tp and Tq, and we are assuming that Tp is greater than Tq, and there are n minus 1 plate that are inserted, so there are n gaps. In this case, two plates were inserted, so there were 3 gaps. Now heat transfer between two black bodies, we know this formula is sigma into A into T1 to the power 4 minus T2 to the power 4. This is our Stephen, where sigma is Stephen-Boltzmann constant. Now suppose there are n minus plate that are inserted, and we are assuming the first plate, that is 0, to be at temperature Tp, and likewise first plate at temperature T1. Similarly, n minus 1 plates have been inserted, and so there are the n plates, and the nth plate is at temperature Tq. So total number of gaps is 2. In case of steady heat transfer, because heat is transferred from first to second, then from second to third likewise, so amount of heat transferred will be given by Ws equals to sigma Ti to the power 4 minus Ti plus 1 to the power 4, where I is the ith plate. So heat transfer is taking between two adjacent plates. So this leads to, in the steady state, we have some equation like this: T0 minus T1 to the power 4 equals to T1 minus T2 to the power 4, and so on. So finally we can get this result: Tp to the power 4 minus Tq to the power 4 divided by n. So the net heat transfer between any two plate is any one of them, that is T0 minus T1 to the power 4 into sigma, or T1 to the power 4 minus T2 to the power 4 multiplied by sigma. So this finally reduces to, when we substitute the value as sigma into Tp to the power 4 minus Tq to the power 4 divided by n. So coming to our question, our original heat transfer was given between two plates P and Q was given as W0. This was when there was no plate inserted, and when we are adding two more plates between P and Q, so the gap, there are two plates, so there are two new plates have been inserted, So altogether there are 4 plates and 3 gaps. So the Ws will be Tp minus Tq to the power 3, and the ratio will be W naught by Ws equals to Tp minus, we will take the ratio, and this value comes out to be 3. Thank you.